they have become business concerns. Now, to discuss and share their insights, we have three panelists. And I'd like to first invite Dr. Lawrence Wee, Chief Data Scientist at Allianz Asia Pacific. Next, we have Dr. Yew Choong Chew, Head of Data Science and Custom Value Management, U Mobile. Lastly, we have Chris Day, Director of APAC Sales Engineering at Denodo. Welcome, guys.
Hi.
Hey, good morning. Thanks.
Good morning.
Hi, good morning. And I hope we are all set for this interesting discussion. And again, I would like to highlight to the audience that if you want to participate in the discussion, please feel free to send your questions using the Q&A button at the bottom. So without much ado, let's dive into the first part of our discussion, which will be on data challenges. And the market is talking about the value of data infrastructure. Now, I'd like to hear from the data scientist's point of view. What does it mean by building a data infrastructure? Just to set the pace. Maybe Lawrence, you can start out with it.
Okay. I think that's a broad term, right? Data infrastructure. I guess the first thing that will excite data scientists is access to large pools of data. It's obvious, right? Without data, you can't do anything. So I think in any organization, it's very important for the data science team to have ready access to large data pools. The larger, the better, right? So this means that they have to access data pools which is residing in enterprises or entities which is outside of where they sit. Right. For example, if we look at a big regional office, the data scientist is housed in a regional office. They will want to have access to data sets which is sitting on entities which is outside of the regional office. Right. So, for example, in Singapore, if this is where the regional office is, they'll be looking at data pools or data sets coming from Malaysia, from Indonesia, from Philippines, and so on and so forth. Right. Now, in some organizations that I've came across or I worked with, it's quite rudimentary, right? So access data infrastructure is quite minimal. So how data scientists access those data sets is simply a CSV file transfer. Okay, it's a very simple the connection with entities outside the regional office, and then they would export the CSV file over. In some organizations, which is a little bit further along the data infrastructure pipeline or kind of runway, they would have a more organized data warehouse with proper ETL processes in place where the data sets and data pools residing in the entities outside the regional office would be piped in directly to some kind of a central warehouse. And then the data scientists will access it quite readily without having to schedule like a CSV export, from the different entities outside of the regional office. So I think, to me, data infrastructure, the key thing is ready access to data sets for data scientists. All right. If a simple CSV file works, okay. If it's more convenient, or it's much better to have a centralized data warehouse with very strong, robust ETL processes in place, then that works too as well. But actually, since we're on this topic, I know there are more exciting tech around this data infrastructure space. I mean, it's good to hear from the other panelists. What's new? What is it that could excite the data scientists even more, right? Or reduce kind of that workload, or pull down the limitations and the barriers to data access. Yeah.
Thank you, Lawrence. Just want to dig a bit deeper on what you mentioned. We are talking about ETL, looking at how data is going to be transferred to you. Now, if I'm not mistaken, like 3 to 4 years back, CIOs and CTOs, they were more concerned about ETLs and how data has been transferred across. Is that your concern now?
Well, so like I said, I've worked in a number of organizations. Interestingly, they have different philosophies and perspective around this issue. So one of the companies I worked with, that's this big issue, right? So they want to centralize everything, right, into one common data warehouse with proper ETL in place. But in another company that I worked with, they seem to be okay without having this central data warehouse. So I think the question to this is, the answer to this is, it depends. Although I have a sneaky feeling that the future will be a lot more centralized, right? I mean, a lot more organizations want to streamline processes, make everything centralized. It's just easier, right, for compliance, for regulatory purposes, and for the digital teams. This is a godsend because they have now access to bigger data sets. They can see things at a macro scale. My feeling is that we will move in that direction, but there will be companies along the trajectory. Some will be ahead, some will be behind. So yeah, I guess everybody's on a journey, right? It really depends.
Thank you. You, or should I call you Dr. Chew? I'm just wondering.
Either is fine.
Yeah. Now, from your perspective, could you highlight to me what you mean by data infrastructure from a data scientist perspective, especially from your organization?
Okay, personally, I think the data infrastructure is really, today, when we talk about data infrastructure, it really depends on what is your data strategy. All right, I have this feeling because in my last 2 working experience, all right, I have 2 different approach. So previously when I worked in a bank, you see, they already have, right, like many traditional organizations, you already have all these database, whether you like to call them silo, islands or whatever, right? Every department, every division, they have their own database or databases, all right? But then what is the strategy? Is the strategy to consolidate all, or you agree to that it's too expensive to change them? So you just keep them running for whatever purpose, and then you look for another strategy to address your new need. So to me, it has to come from a data strategy that clearly set the goals. Are you building or improving your data infrastructure to address operation, analytic, or governance? Okay, in the bank. So when we actually invite one of the big 4 to come in to help us to do data strategy papers, right? So initially, the big 4 actually, offers a few options, right? Eventually, everyone decided, right, it's too expensive or too risky to change to the existing infrastructure. All right, so we decided to actually take one of the suggestions and start to build this data science or advanced analytics, we call it something new, modern, right, as a separate track. All right, so for that, the bank actually come up with a center of excellence, look into this. So for that, whatever infrastructure, technology, the process we introduce or people we hire is purely for analytic purpose. So, after I moved to the telecommunications, right, so we also doing something similar again with another consultant. But this time, the goal is actually different. In my current project, right, the data infrastructure we are building or expanding have to address operation, have to address analytics, and also governance. So where is this operation coming from? Because in this data infrastructure we're building, it's not only consisting the traditional data warehouse, but it must have also integrate with this so-called, today we call it the data lake, that taking care of those unstructured data side. But more importantly, is like, everyone is actually complaining, right? In the traditional data landscape, there are too many silos. Everyone have your own definition. We don't have a single version of truth. All right. So in order to achieve this so-called single version of truth, all right, the easy way of thinking is, oh, why not we just, integrate all the data from different sources to one place and then find a way to consolidate it. But actually, it's not as simple as that, right? So in order to achieve that, not to mention or considering the complexity of the technical part of it, we will actually come up with things like, do we have a standardized data definition, data glossary? Where is your metadata management? Where is your master data management? All these kind of things, right? In the end, it all comes under this data governance umbrella. All right. So whether we are doing, whether we are supporting operation, where we can't actually alter the facts. We have to report the facts, right? Because you can't go out and tell your shareholder, all right, our number is this, but I think there's a plus or minus 5% variance. People want to sell it, right? You can't tell shareholder this kind of thing. But when you do analytics today, whether you do machine learning, you do AI, it's a prediction. All right, it's actually tell you how likely this group of people will buy or subscribe to your service or product. All right, so then the last part of it is the governance, right? So whatever governance you put in is just to hope that everyone handling the data, or managing the data, understand there's certain SOP, there's certain best practice they must keep in order to ensure the data quality is there. Yeah, so to me, really, yeah, for the data infrastructure, it really depends on what strategy you're applying. Yeah, that's my view.
Okay, I mean, that's good. And we will later on go into data lakes, different forms of data infrastructure, as well as what you actually touched upon, which is, I think, very important, the importance of data ops in a lot of organizations. But before I move to Chris, just wanted to ask, when you say that we need to have a data strategy right up front, and data governance should be right up front as well on the onset and with that strategy, to what extent does a data science team voice matter as opposed to the other C-suite? Or is it a collaborative effort, or has the conversation changed?
Okay, this is really based on my personal experience and knowledge, right? So I'm not saying this is how it should be, but in all the projects I involved, right? So that, you see, people see data scientists as a new aliens. Right. Many top management, they hear big data, they hear machine learning, they hear AI. When they go to all these top expo, they see, wow, sexy things, right? Yeah, then they come back and say, hey, we must do this thing. Consultant also tell them, you must do this thing. But I'm sorry to say that not many of them actually really know what is happening there, right? So in the end, all right, the decision has made by top management. All right, the strategy has crafted by your consultant. In the end, when these things executed, it go to the working levels. All right, then you have to deal with all the so-called those HODs or people that might not make decision but has the power to do the day-to-day operation. And these people, they're all different. They might know what you're talking about. They might not know what you're talking about. You get what I mean? In my experience, it's really like, yes, I think the challenge is really communication and getting people to understand what is it all about. And, traditionally, generally, most people is, very afraid of changing the way of working. So I personally think that most of the time, right, from a data scientist perspective, right, so we are actually playing around like an in-house consultants. All right, so we have to introduce what is this new things to the existing group of people, and somehow not only educating them, but have to find a way to work with them, to let them know that, right, things is not so, especially if you work in financial institutions, right? People is resistant to any changes because it's not tested before, right? So everyone is actually afraid to make changes because they cannot take risks. All right. So I think that is like there's a part that you really have to spend a lot of time to communicating. You can't force them to work your way. All right. So you must find a way to communicating with them, make them understand, and also most importantly, in the end, you must also change the way you're working. You have to adopt some of their culture, practices. All right. That's why I think every data infrastructure or data strategy or data science project, right, you have to change it here and there a bit to suit that particular organization culture. Yeah.
Thanks, you. And Chris, you're in an unenviable position where you need to actually work with companies, sell the idea of a data infrastructure, but still work with the different definitions and come up with a common purpose. How do you actually engage? What are the tips? What are the lessons?
Thanks, Winston. I mean, you say unenviable, but I actually find it quite exciting addressing some of these challenges because as both Lawrence and you have outlined, it's more than just technology. It's just about, can I get the data? It's all of the people, how they feel, the culture, their common understanding. And so that's very important when we start to look at information architectures or data architectures, to take in consideration across the whole landscape how those people are currently using that data and where they want to get to. So I wouldn't go as far as calling it a maturity assessment, but fully understanding what their needs and their wants are by the time we finish. And then it's taking those into account rather than forcing in a specific technology because it's the greatest, newest thing that will possibly solve their problem. So it is very much taking them on that journey, understanding where they want to go, handling the objections and fitting in with their culture rather than just trying to change it, to upset it, to disrupt everything. That's how I like to approach things from a technologist anyway.
That's interesting because Lawrence and you actually highlighted an issue where sometimes it's an industry and it comes down to the organization. And you mentioned that maybe you might want to do a maturity study, but it all depends on how you actually engage with the culture. But how do you actually prepare a company to understand that to have a very efficient data infrastructure, you might have to change the way you work?
Sure, that is probably the biggest thing because technology can be quite easy. It does what it says it should on the box, and away we go. And that is a long-term engagement, and it's bringing them along on that journey. It's getting executive sponsorship. It's understanding how what we're trying to achieve and where we're trying to go actually aligns with the corporate goals and the corporate requirements, so that we can show them, well, if you do it this slightly different way, then you're going to achieve your goals far, far quicker and make everyone happy. It's just showing the value. And sometimes, yes, we do have to significantly change those processes and change the culture. But to use point there, I think it's also a case of showing them that your way is better. So sometimes it just comes down to showing them, like, let's prove this is the case. And you get agreement that says, well, if I can prove that this way is better, will you do it? And, so it's bringing them along by example, we'll say.
Okay, so it's a journey. Lawrence, you mentioned about looking at different data sets, and no matter what, you like to get pipelines, maybe connect to the different data. But as a data scientist, you know that not all data are created equal. In fact, the biggest problem is data are not equal, and every data has its own quirks, and normalizing them, standardizing them, preparing them is one of the biggest issue. How do you handle that from your perspective?
Right. So maybe I can bring out some examples. At Allianz, for example, as a regional office with different entities throughout Asia. If we're just looking at, for example, medical or health insurance claims, you would imagine that there are certain data fields which are common, right, which is across all the entities. So they use the common fields, the common variables, and they all look alike, which is good, right? There are other fields which are quite different, which is peculiar and specific for different markets, all right? Now, if you're talking about data integration, the biggest issue here is having some kind of a master data mapping, right? Or to harmonize all the data fields together. And this actually is a lot of work, right? Because you need to actually speak to the data owners of each entities and to find out what those fields mean, right? So to me, I don't think this can be automated too much. I mean, maybe a little bit, but not too much. I think like 90% of the time, it's about speaking to the relevant stakeholders who knows the data and is able to explain to you what those fields are. So as much as we love automation, as much as we love data integration, you can't skip this step, right? So I think to us, the biggest bottleneck here is the effort required to understand what those data fields means. I mean, from the perspective of data integration, all right? But once you know what those fields are, it gets easier after that, right? So you know which one you should remove, which one should include, how to map each of the fields together. So it's just a lot of work, right? Actually, a lot of manual work understanding what the data fields are.
I guess it also means that you will be having to collaborate and talk with the different data.
Yeah. So there's a lot of people relationships here. You know, when you're in a data science team, you actually spend a lot of time getting to know people, getting to know the actual business problem. So like what you said, we are a lot like an internal consultant. So the relationships that we establish with stakeholders in the company is very important. It's not a transactional one, right? It's more like a longer term kind of relationship, because you never know everything from the start. And as you know more and more about the business unit, you know more about problems they faced, the data issues that they face, right? So it's like a business relationship, right, with different units of a company. So internal consultant is the right word to use here.
Or a business partner. Do you see yourself as a business partner for your?
I mean, most of the time. You tend to, like what you said. You just don't just educate, right? You also have to, do the work, and then you have to change their perspective, inspire them to do something different. So you play many roles, right? So as a data science team, you play many roles in the organization. You're not just a technical person, right? Obviously, the more junior members are, but the more senior members will be required to take on more relationship building skills.
Same for you.
Mm-hmm. Yep.
Do you see yourself building a relationship and becoming a business consultant, as you mentioned earlier, to your entire organization?
Actually, sharing a joke with all of you. The reason I quit bank because I don't want to be a business person. But anyway, yes, like I totally agree with Lawrence. Right? If you are junior, even like I always ask my junior focus, to upskill your technical knowledge, your skill set, because that will help you along your career. But when you move up the ladder, you become more and more senior. All right. No matter how much you love it, all right, unless you really go to do your own startup or go back to the R&D where you really focus. I was in R&D before. I can spend 24 hours do coding without talking to anybody. All right, but in business, no. Business means business. All right. Everything starts from the what's the value. If I invest this $1, right, what's actually people care about? Not care about how you're going to use it, what people you hire, what technology you buy, what process you're going to change. People just ask you, what's the ROI? So for data scientists, I think a lot of data scientists actually have this challenge because they're technically good, but I think they don't know the business well enough. So I have learned this for past 10 years, even myself. Right? I used to be very technical people. Like I say, really work day and night in Japan, not going home, also lock myself in the research lab, not talking to anybody, purely do technical. But when you go into the industry business, all right, people will only talk to you, maybe start to trust you if you actually know their business pain point and you show them, you can help them to improve. So that is very important. So today, when I train my young engineer, well, I still want them to focus on technical thing, all right? But I always challenge them to, whatever they're complete, they need to do a presentation slide. They're able to communicate their finding, their result to the business people in the layman term. I think that is actually one of the crucial things for every person doing data analytics, not only data scientists.
That is true. I mean, I think it cuts across all the levels. If you can communicate in layman terms, I think you are the best person to actually articulate a lot of ideas. I'd like to bring Chris. Chris has a presentation and he will give us the context for the next part of the discussion. Maybe actually we will dig into the technology part as well as the solutions. So I'd like to invite Chris. Chris, virtual stage is yours for the next 15 minutes. Over to you.
Thank you very much, Winston. Yeah, and you know, it's a really interesting conversation that we're having already this morning. So fantastic. And what I'd like to do is introduce virtual infrastructure or logical architecture and how it can in fact assist with some of the challenges that we've spoken about this morning. So just as a brief agenda, let's introduce the topics of what is data virtualization, how data virtualization fits within an architecture, and then look at some of the patterns, but primarily around data lakes and the benefit of a logical data lake, and how this would assist us with tackling the challenges around delivering data to our data consumers, whether we're talking about data scientists or our analysts or even the business users that are trying to use the outcomes and the value that we're enriching our data with. So the place to start is, what is data virtualization? So really what we can see across the bottom here at layer one is all of these disparate data sources. All of our organizations will have them widely distributed across the information landscape, ranging from relational databases that have highly structured data through to our big data platforms such as Hadoop or some other cloud-based data platforms that may have semi-structured data, and even to those file systems that will have unstructured data. How do we bring all those together and actually present them out to all of our data consumers that we can see across the top here with the very varied requirements that they have? We have both operational requirements and real-time requirements for our data so that we can get as the business is running now, as well as satisfying those advanced analytics and machine learning initiatives to sort of start to predict and get ahead of the curve, as well as just governance. How do we govern all this data? How do we enable our stewards to add value and documentation to it? And in the middle here, we have the data virtualization layer that takes and connects to all of those disparate data sources, harvests the metadata, combines it together to enrich and build our enterprise models, and then publishes it out for consumption. So it's a pattern whereby all of that disparate data in each of those locations actually stays in those source systems. So an example might be a enterprise data warehouse that we're trying to blend data into with some Excel spreadsheets. All of that data actually stays there, and just using the metadata, we can combine them together and build a new model. As we go forward and have a look specifically at Denodo and how Denodo provides this data virtualization architecture, again, we've got all these disparate data sources and we've got all of our different business solutions and business consumers. But in the middle, we have Denodo as a data virtualization platform, the ability to connect to all of these disparate data sources, wherever they are, whether they're in cloud or on the premise or across multiple cloud providers, combine it in a consistent and unified model so that we are building those corporate entities, those customers, assets, locations, things in a consistent manner, and then publish them out for consumption. Surrounding these core capabilities of the platform, we're enabling other abilities. So the ability to develop really with high agility and to plug and play our data sources into our enterprise data model, all the while ensuring that we're doing this with guardrails. So doing it in an environment that is secure and that has a high level of governance. This means that now all of those disparate consumers, whether we're talking about the person using the Excel spreadsheet or the person using the machine learning tool, is getting the data in exactly the same model with exactly the same security model. And then coupling that in with the other capabilities of the governance, the centralized metadata so that we now have a platform where users can go to and shop for data, find the data that they're interested in, and understand the documentation, where it comes from, its meaning, where it should be used, etc. This also lets us start to do the full governance program around lifecycle. So when is this data valid and when should it be archived off? If it's archived off, who should have access to it? Answering these questions. So it's a platform that allows you to be very flexible, but also to deliver these enterprise capabilities that organizations are looking for. If we take a look at this specifically for data science or advanced analytics, what we can actually do is to use data virtualization to build up a logical architecture. What we're seeing here is a logical data lake, where it's a virtual or a logical boundary around all of our physical assets. So while we still have a physical data warehouse, we still have a physical data lake, now we can virtually connect them together without having to copy data backwards and forwards to fill our gold standard enterprise data warehouse with data that's not of a gold standard. To copy all of the data warehouse into the data lake, we no longer have to do that. We can join them together logically. It also minimizes the requirement to build up another silo of data, just so we can blend something together for a particular initiative. That's the logical architecture, and what it actually does is present out a semantic layer to our business consumers or our data scientists, so that now they can talk about things, objects, nouns, entities, rather than having to worry about the point-to-point connectivity into each of those underlying data sources. Because it's all managed by metadata, a centralized metadata repository, it means that now we can simply explore an option, explore a different data model, and if it's not right, we just change it. We just change that logical model without having to go back and reprocess all of the data. The other value of this is it presents all of this data, regardless of whether we're talking a software as a service application that delivers data out as an API, or whether we're talking an enterprise data warehouse, or even a file system. It presents all of this data out in a consistent interface. So it's not that we don't want our data scientists to be looking at cutting edge information, cutting edge technologies and capabilities. It's now that we can use a single interface, a SQL-based interface, or a REST-based interface, or a OData-based interface to get all of that data, regardless of what the tool does. And that's really what a logical architecture is. We've titled this one a logical data lake. It could be titled a logical data warehouse, a logical data store. It really comes down to the level of governance and the capabilities or the uses that we want to deliver based on this logical architecture. If we take a look at how this would impact the data pipeline problem, the way that data scientists and advanced analytic practitioners get their data. To introduce this, I mean, we can introduce this data science workflow, which you're probably all very familiar with, whereby it's the multiple steps of finding the, well, first setting the business case, finding the data that meets it, you know, preparing that data, getting it ready for our algorithms to run the algorithm, test it out, and then we go back through the cycle. And so what happens is that these steps 2 through 5 become very repetitive as we go through, find the data, test it. Based on the outcome, we go back, we find more data, test it, et cetera, et cetera. And it really does take a lot of time because traditionally, these are all physical steps in that every time we find some data, we copy it into a new repository, we have to reprocess it, et cetera, et cetera. And so it is time consuming and uses a lot of resources. But if we take a look at these steps, we can see that really 80% of our time goes around finding and preparing the data, whereas really only 10% of the time is around the actual analysis, the actual visualization, the presentation of that to our business users, the stakeholders in this whole journey. Why does it take 80% of their time? Where does all this go? Well, it can vary between finding where the data is, actually asking and getting the right permission to the data. So working through our internal processes, getting data into a consistent format, a consistent shape across all of the disparate data sets that we do, and then making sure it is ready, that it is cleansed and of the right level of quality to bring the right result that we're looking for. We can accelerate this, so this first step around identifying useful data, by using that metadata, that centralized metadata, in the shape of a data catalog or a data dictionary, where now as a user, regardless of whether I want to do in-depth analytics or even if I just wanted to do an Excel spreadsheet, I can now go and find all of the data in the platform that has to do with customers, understand it, see where it comes from, and see whether I have access to it or not. I could even go and ask the SME or the data owner to see, well, what does this particular field mean? But now I've got that centralized place where I can collaborate across the whole organization. Once we've found where data, the next steps around modifying it into a useful format, doing the analysis and preparing it for the algorithm testing can also be done logically. Because we're now building that logical model, that standardized model in a standardizing interface, we can do all that cleansing on the fly, in real time, rather than having to go back and constantly reprocess terabytes of data. As I said before, this means that once we get to a model outcome, we can then just go and change the model rather than having to re-ETL, re-deliver all of that data. It makes it very, very agile and quick. So just as some quick takeaways, a quick summary, data virtualization as a technology within your information landscape allows you to reduce the cost by increasing the speed at which you can deliver, as well as reducing the amount of infrastructure that you're actually requiring to deliver an outcome. It also gives us that platform that we can collaborate and share our understanding of what the data. It delivers data in real time directly from those sources. And it's a platform that you can do self-service and discovery. Within the bounds of your role and responsibility, you can find the data that you have access to. So it's enforcing that centralized governance and security of all your enterprise data assets, regardless of where they come from. And it's not forcing you into using a particular tooling. Whatever tool you're comfortable with using can now be used to consume the data from the platform. Whether we're using a notebook or some Python or R script or even an Excel spreadsheet, we can get access to all of that data without having point-to-point or specific technologies. And so really that's what data virtualization offers us, that ability, that flexibility that we can add to our information landscapes.
Thank you, Chris. And yeah, it's been very insightful. And I think it sets the pace for the next part of our discussion. But before we enter into a lively discussion of what data virtualization means to all our data scientists, I also like to remind everyone, please do ask your questions, use your Q&A, and I think we have a lot of good subject matter experts on the panel, who will be happy to answer your questions. Now, to continue the discussion, maybe I'll pose this to you. You've seen the presentation on data virtualization, but how, as a data scientist, how do you view this issue? Because data virtualization has been a topic for quite some time, but it's only obviously gathered steam recently. So how do you view it?
To be honest, I always see, when people implementing these new data strategies, right? The data virtualization always be the part that left out. I have seen, I work with the different consultants, all right? So in many of the proposals, right? Data virtualization always come in as an optional part. So yeah, in the end, very often we are considered is like, a second phase or third phase thing of it. And as a data scientist, I'm okay with it, all right? Because you see, when we start all these new things, right, like say, most of the time, the organization see you as new areas, right? So they don't know what is what, all right? What they're eager to see is really like, can you come up with something that really able to help the business, something that they can understand and then can agree with you, right? This piece of new technology or whatever you call it, right, really can help the business to improve the business value. All right, that is how I see in the data virtualization. Same so like many of the times when we do data science, machine learning or big data analytics, right? So we can rely on the traditional way to convey our finding with the business. Like I think Lawrence mentioned that, right? So yes, we take CSV file as an input because not necessarily all the time becoming as real time, right? You don't have that many of real time analytic-based use cases as well. So when we run our algorithm, we generate the leads. The leads can come out as a batch as well, right? So I can send, if I automate it with RPA, I can actually send this new list to all the stakeholders via email in the daily format. All right, or I can create a simple dashboard to refresh this every hours. So for that reason, many of the use cases when it comes to the end result, output sharing, we can rely on the traditional method. However, recently I actually relooked into data virtualization, and this is actually my all right. I'm actually looking for something to help me to actually, how to say, do the data monetization part.
Okay.
All right. So I'm actually reviewing data virtualization solutions and also API gateway-based solution. Right. In the end, to a data scientist, right? So yes, now I have some process, some people, some technology able to mine my own data. All right. Although I can't share those personal information with third party, but I can actually come up with something to actually have a real value to the industry. For example, now today in the telco landscape, all right, a lot of solutions actually utilize the API gateway to replace the OTP authentication. Right, a lot of partners when they come up with their new apps, all right, they don't actually need to rely on an SMS-based OTP to verify whether this new registered user is genius or not, right? So instead, they actually have a solution that actually can utilize a telco base, right, to verify whether this new registered user is a genuine person that registered with one of the telco, and right, so they can, this is how we are the direction in telco that we are actually moving to make use of telco data to share some non-sensitive information to assist the business process. So in this case, I come to know API gateway more, and seems to be more direct. That because when in not all, but in many of the API gateway, they actually come up with some the monetization module, right? When we use the gateway solution to create API to share data with third party, we can define different type of pricing model, right? For example, you can subscribe to a basic package, which allow you to utilize our API for maybe up to thousands times a month. Then you reset. Or I can come up with another package like so like it really depends on the usage. Every API call will cost you maybe 0.1 10 cents, things like that. I don't know whether in data virtualization it has something similar, because I look at it, they are actually serving almost the same purpose, almost, right? You are actually simplifying the process of sharing data with the party without the consumption side need to really know SQL, need to write any programming or script, things like that. Okay. And also govern the proper securities. Yeah.
I think Chris did talk about the security, but the way you look at it is simplifying. I think that's quite a poignant point. Lawrence, what about yourself? How do you see data virtualization from your perspective?
I think you when he brought out the example of the API gateways and working with partners, I think to me, yeah, the first thing that struck into my mind is the potential for this data visualization to expand the opportunities for an organization, right? So, meaning to say that more potential to work with third parties. Just an example, right? For an insurance company, you know that they work closely with banks. So bank assurance, it's a concept that involves the banking partner working closely with the insurance partner, right? And they're distributing the insurance product through the banks. There's a lot of talk about banks and insurance companies sharing customer data and analyzing this cohesive data set together to target the retail customers better, right? But the issue here is the sharing of data between the two very different entities, right? A bank and an insurance company. So you can imagine that there's a lot of pushback, right? There will be a lot of pushback. There are a lot of pushback currently between banks and insurance companies on sharing data. Imagine, we can use a tool like a data virtualization layer to facilitate some aspect of data sharing. I'm not saying everything, but perhaps a little bit to make it easier for parties to access the other party's data. If it lubricates this collaboration, then I think it serves a very good role here. I think because this is a very big industry problem, right? Sharing data across different companies for a common good, right? I think if technology can help to facilitate or catalyze this collaboration, I think to me that's excellent, right? I think this is more lucrative, has more potential than doing it just simply for the organization.
I agree. And Chris, we are talking about sharing across organizations. Where does data virtualization come? And also I want to also dig a bit further on data virtualization. It's not a cure-all. What needs to happen before data virtualization that data scientists need to know about?
Yeah. Thank you, Winston. And yes, it is definitely not a cure-all. There are still spots in there for the traditional technologies, for our data warehouses and for our data lakes, and all of those technologies are still there. And we spoke before that one of the hardest things, Lawrence mentioned, one of the hardest things is just getting that agreement and understanding of what the data is all about. That still has to happen. As much as we'd like to have an automagic system that just picks up the context and delivers it, that still has to happen. So, it is a requirement that you still understand your data, you still understand the relationships between the data. But having done that, now you can centralize the model, centralize all of that understanding so it can then be utilized, whether we are talking about delivering it through an API to an internal or external customer, or even if we're just talking about doing financial board reporting, it's now centralized. When we start talking about sharing data, whether we also see that same issue about whether we should or shouldn't share data between different lines of business within large organizations. And what data virtualization allows you to do is, I suppose, divide up the areas of responsibility. If we look at a whole enterprise and the extensive entities and models and relationships between each of the entities within an enterprise data model, it's very hard for one person to manage that. But data virtualization allows you to divide that up into lines of business or domains of expertise or areas of responsibility, areas of security, for want of a better word, so that you can manage that and ensure that you, as a line of business, as an organization, are meeting your regulatory requirements around privacy and data protection, and only sharing out to the external organization or the external line of business what you're allowed to share. So this means that you could monetize the internal data and just share out trending data. So rather than actually shipping out raw data sets, you could just ship out the results of some analysis that you've already done that can then be purchased and used by an external body. Equally, it allows you to take assets that have been developed externally. You know, I'm based in Sydney, so a lot of the government organisations use assets that are developed by the Australian Bureau of Statistics. Now, they don't want to ship and own all that data. They just want those insights. And so data virtualization allows them to plug those insights into their corporate information landscape and leverage them totally transparently.
Okay. Lawrence, I was just wondering, Chris was talking about how you can actually share data, and you can actually have input and output of data, which allows you to build models. But I'm wondering, looking at it from a data science team, does that mean that you have to build your data science teams to have domain expertise inside? Or does like a model like a data virtualization makes it easy for you to access domain expertise in different parts of the organization? The reason is domain expertise is important for interpreting the results of a data science team.
Right. So I think for different industries, different organizations, the requirement for domain knowledge will differ. Let me just bring up one example. If you're a data scientist in a healthcare domain or medical science domain, it's actually very useful to have some biomedical, or healthcare knowledge, because the data sets you encounter in health is actually quite different from the data sets you encounter in e-commerce data or the more general mass market industries, right? Just one example, right? In healthcare, there is this thing known as the International Code of Diseases. It's like a 4 to 7 letter code that describes different types of diseases. Now, if you don't have medical healthcare domain knowledge, you will struggle to understand what this data means. All right. Whereas, if you are in the e-commerce industry, you're a data scientist, you're looking at transaction data. Common data fields would be the item name, the date, time of purchase, the amount paid, things like this. It's to some extent you can guess the meaning, right? So if you're a data scientist, you're looking at those data sets. If you've seen enough of it, you sort of know what it means. But in certain domains like health, this is challenging, right? You cannot guess it. Okay, you have to study and you know it. You must know it. So you actually have to work with someone who knows it. So there's a lot more collaboration, in a health data space. So it's always good to get data scientists who have that kind of prior domain knowledge in your team.
But it's difficult, right? I mean,
yeah, well, it's harder to come by. It's good. It's good to have. It's really good to have, right? But I'm not. But if you can't find one, it's okay. You can always start from baseline and then build up the knowledge. But it helps to have someone with that domain knowledge. Certainly more in health compared to other industries.
Hugh, what about in your industry? The question was, when you have data sharing, enabling data sharing, how important is domain knowledge or domain expertise to be part of your team, not just being part of an organization?
It's very important. All right. So whether it's a part of organization or external domain expert, right? So it's actually one of the key success factor to, for whatever use case you want to implement. I have experienced with working with external domain. We purposely hire it's so unique, right? So for example, all right. So it's nothing common in the general data scientist knowledge and skill set. We have to hire people that really have the experience and also know data science and external experts to come into the project to help us. All right, but then other than these external factors, right, as a data scientist, I think there are two things you need to ensure if you really want to make sure there's a successful data science use cases. First of all, every data scientist should really spend a lot of time to do a lot of reading. All right, so of course you can't really earn the real knowledge and experience before you really involved in such a project. But today, a lot of information is actually publicly available. You actually can read a lot of research paper in different domains and how learning from those experts, how they actually apply data science or machine learning to break through some traditional challenge. That is the part you can actually try to learn from the knowledge side of it. And then in the practical side of it, right? So very often when we do data science, right? So we actually will together we will propose a so-called agile approach, right? So very often each of the data science team will actually come up with their own agile analytic approach or framework. I mean, internally we call it the agile analytic framework. In this framework, it will actually come up with the best practices, like, you know, how do you run analytic use cases, and who are the stakeholders, what roles they are playing. So in this agile, you know, analytic framework, it's more very often that the business domain expert need to be part of your agile squad, right? Because and you can see in this whole framework, the very first things right after when we have a business requirement or business problem to solve is the second step is really to define the success factor. And that actually have to come from the business and agree by the business. If it's not, whatever you do, right, in the end, business don't accept it. It's a failure. So I think it's very important.
What do you think about that, Chris? Because you've been working with a lot of projects where you have different data science teams, and obviously there is also an element of having domain expertise. How do you see organizations actually solving it, and keeping in mind that Denodo themselves have a data science team? So I'm just wondering, how do you allow your customers to leverage your own assets?
Yeah, look, it's a problem. It's a challenge. It can be a challenge because, you know, both as Lawrence and Yew have outlined, you do need that knowledge. So Denodo as a platform, as a technology, is not going to give you the domain knowledge around medicine or insurance or even retail. That's not going to happen. But we can give you the platform that enables you to collaborate and share and get a consistent understanding of both the knowledge and the outcomes that you're using. So the whole life cycle of that. Internally to Denodo, what we're doing is leverage our own platform so that we can use all of the metadata that's present, taking, you know, into account the usage patterns, the security model, the available data sources, basically putting all of the operational and technical metadata together so that we can come up with the most efficient model for delivering data. That's really what we're doing. Now, it's not until we add the capabilities and the understanding of your domain experts that data actually means something. But it's all based on metadata. It's all based on a common governance model, a common level of documentation. And that's how we assist organizations with going from wherever they are to wherever they want to get to.
It's always interesting to go from one level to one level higher. First of all, we are actually coming to the end, and if anybody else has questions, please feel free to ask. We will answer in the next session as well, where we actually will dig deeper into the different technologies. So at this moment, I will say thanks, Lawrence, Yew, and Chris for your insights. It has been really good. And I'm sure a lot of our audience would have learned a lot. And I learned a lot from you guys. So really thanks for everything. And now we will take a short break, but don't go away, because during this break, we will be serenaded by Nicole Lowe and Teddy, and they will be singing to us some famous hits. And then